This is one thing in physics that has bugged me for a very long time. And the reason why I've come up with the theories I have come up with. Why a clock at a mountain or on a plane versus ground level behave differently. And just saying that even if the clock is absolutely perfectly matched, I mean, there's a I don't know, an unflawed similarity between the two clocks, that they each, given the same elevation and velocity, will never tick off of one another separately or differently. It's really early. I think it's 3:30 in the morning. But the reason why this happens, now, in philosophy, if you create a constant, or you create your foundation, as you do in science, your fundamental, your what constant is in an experiment. Well, time, if you remove all matter in the universe and create a perfect void, that void, even at a sub-quantum level, to where you can have infinite density or an infinite void, it doesn't matter how, once you shrink down small enough, there's still empty space. There's not really anything there unless you have a sub-quantum particle that makes up reality. And so when you remove all matter, time still exists, and in two separate positions, say one with matter versus one without matter, versus a state of perfect infinite density like at the center of a black hole, time is still existing theoretically consistently. It has an infinite velocity and an infinite density. Time, now they say there is no such thing as absolute time. You're wrong. It's just that we don't have a way to measure time. That's the thing. You're looking at it differently. I mean, I don't understand why people think that gravity is warping time. No, it's warping quantum atmospheric density. It's warping the electron fields. That's what it's doing. I mean, that's rational. That's logical. That's not, what do they call it? An illusion. Time is an illusion. Yeah, I guess you could look at it that way. I forget what I call the three states of time. It's been so long. And since I don't talk to anybody about this stuff, except my own self, I've decided lately to make these videos to explain all these things. And so, when in my gravitational field model, it explains how Einstein saw these things, but in a way that I can understand, and I think other people can understand more simply, using words that in modern times haven't changed their definitions as they could, say, 20, 30, even hundreds of years ago. Definitions change, interpretations of words change. And so, when people say time, in classical physics, it's completely different than what I interpret time as, because I had to figure it out on my own. And through many roads leading to the same conclusions, in philosophy, we can then prevent the change of definitions from confusing the mind away from real practical physics. And we can constantly, by generation, keep an understanding and translation from the illusions of words and misplaced meanings, misplaced interpretations. So why a clock behaves differently at different altitudes, it's all, as I said, relative, yeah. But what does that really mean? What is this warping? I mean, why do you even think it's warping? Why can't you align the two and say, just because I travel from point A to point B at 1,000 miles an hour versus point A to point B at 1 mile an hour, that yeah, when I arrive there, I'm going to be younger because it takes 1,000 more hours for this particle to get to there, because it's traveling 1,000 times quicker. And so what happens at a point closer to Earth versus in space is not time dilation, unless you look at time like classical physicists do, which took me forever to understand what the hell. I always like, the only way that this would make sense is if there is an electromagnetic pulse and the electron field is time to them, and that's exactly what it is. So at space, the quantum atmospheric density is less. As you go down, it shrinks. So time warps because of the length, the circumference, or the radius from the center of a molecule or an atom changing its quantum atmospheric density. And that's what led me into my gravitational field model. It's just, I can't understand it any other way. So when you say time, well, that's such a bland word. I mean, it can mean all sorts of different things. To a philosopher, it means existence between two moments. Whether or not there's change or not, it's still the ability to have one idea, another idea. Otherwise, if there is no such thing as time, if time even pauses, how long is time paused for? And so when you shrink down to that fundamental, is time having an infinite density and an infinite velocity, all that you realize is we are measuring time and our measurements are warping. Everything we do is flawed because of that. And you look, when you start to engineer things and invent, there's always a flaw. Time, it takes time and inertia to transmit energy. I mean, the nuclei of atoms have to displace. Electron fields have to interact and interfere with one another. And there's still just a moment there before acceleration and inertia is applied. And going back to this guy, which I love scientists that are willing to take the extra step into something that isn't substantial to real physics in modern times. It's called the imagination, and it's just letting yourself enjoy physics. But this, I think, is really silly. A high-frequency gravitational wave generator. Now, if it works the way he says it does, the particles that make it it's just gonna fall apart. So, I mean, it's a little bit silly to me. And it also just gives you so much more to think about than how boring physics really can be. So just hopeless. And so physics without time, the state of things, and the difference between past and future vanishes. Yeah. It's another way of looking at it. Time, the past and future vanish, because, like I say, from point A to point B, There we go. I was working on a drawing, that's right, to explain this. So, here's T. Time is, it's like inertia, it's acceleration, it's difference, it's, but as I say, I mean, if you shrink down to a quantum level, a subquantum level with a perfect vacuum, and some physicists believe there is no such thing as a perfect vacuum, well then, there are no particles in subquantum particulate matter, and I used to call it quanta, but anyway, so time travel. This is what I was gonna make a video about last night, but I didn't. A to B, B to A to B, A to B. So this would be time travel. This is our normal passage of time. But they're the same, right? So what would be the difference? Well, you are returning all energy back to where it initiated from. And that would be time travel. Since time is a electron orbiting, it would be that electron returned back to its initial state without any quantum decay. And so A to B, and this is me trying to explain how a person traveling through time experiences a complete eradication. So you can't make the same particle. I mean, there's only one particle that can exist in one vector in one position at a time, and so when you travel back in time, you are erasing yourself from reality, so that if you can isolate yourself from the event, then you're fluctuating between these B's and A's, and your particles are removed, so everything you've ever experienced, you won't be there for. Everybody will be doing the same things that if they interacted with you. It's just that you're not going to be there. And if you were to, say, stop the event at that moment, people are going to not have memories of you anymore, but they're still going to be doing something. They're not going to know why they're even doing it. And as you travel further back, you're not going to be born. Somebody else is going to be born. Your particles still exist, though. Your matter still exists as it is from that point on. And this is how you solve those time travel paradoxes. Everybody likes to, and they're fun. It's just, so this is true time travel. So as you travel back, resets the variables, resets the probabilities, but also erases you. I mean, you're completely gone. And in a lot of contemporary like sci-fi, it clones you. And no, you would travel back, and the matter that makes you, your sperm, your egg, is gone. But your mother and your father still have that genetic data, those eggs and that sperm, and they have another child, and it's another probability of a different sperm that made it instead of the one that made you. As we know right now, the odds of you being born is what, 1 in like 50 million or something? And because a woman on average has about 50 eggs, I mean, something around there, 30 to 50. And then the average male is 15 to 50 million sperm or something. But anyway, so that's just another way of examining the reset probability from the event of time travel. And when we look at gravity and quantum atmospheric density and how velocity warps because of this, well, time then on the atomic level from a clock, whether it's, I think they use atomic clocks, right? They don't use a Swiss escapement or something. You know, the hairspring obviously isn't going to behave the same at different altitudes. Not even just biometric pressure, is it? Atmospheric pressure changes in velocity changes from the center of mass, and why planes take the paths that they do. It's just, I'm losing my point perspective here. Okay, so yeah, at the atomic level, at a change in quantum atmospheric density of the electron field, the distances of particles change, the length of travel for the orbital changes, and the nuclear mass sort of changes a little bit too, even. And I said, it's a pet peeve of mine. I really wanted to make, I'm probably going to elaborate more on that maybe again, but that's another thing, like why you can't change anything if you travel into the past. It's because you effectively erase yourself. So you'd have to be outside of the machine, and then it would take you back to a point where you aren't even going to know that you did it, because your memory is going to change with it. God damn it, what was I saying? I was talking about time dilation. So quantum atmospheric densities change, so the clock behaves differently because particle interference changes. The interference patterns change, and this goes back to, say, my laser right here. I want to make my interference pattern, and this doesn't fit in there, and the real battery it takes, you can't buy anywhere. This is the battery it takes, and you can't get this battery anywhere. I mean, this is technically a weapon, but... So I was shaving that lithium battery down, and now it starts stinking. Probably poisoning me. I really don't know the chemistry of lithium vapors or whatever the hell it's emitting, but so I can't make my interference pattern to demonstrate this, but interference warps time. Gravity doesn't warp time. Gravity is what I explained it to be. It's an average electrostatic impulse that is reversed to the center of mass to push matter, not pull it. And you can't, maybe that's why everybody likes string theory. Like, how do we pull something? Strings. Well, everything I touch is like, there are other explanations for this where you're not actually touching anything, and at the quantum level it's interference between electron fields, quantum atmospheres interfering with one another. And so so early, I'm losing my train of thought. That interference, because of the double slit, and it's not just the double slit, it's how you can make interference patterns that really demonstrates how an object that is straight or flat or curved, or it's it doesn't matter if there's two slits. What's really happening is just like the theory that we never actually touch anything. We are only exchanging interference, and that's how photons behave, that's how light behaves, and that's our quantum atmosphere. Is this, see, I look at reality completely different. I can understand how people think it's a hologram. I can see it physically and naturally. I can see it as innocent as I did when I was a child. And before then, I thought, I didn't think light reflected. That blew my mind when he explained that to us. That light reflects, and that's what we see. And I was just like, oh. It teaches you a new way of thinking. Eventually, you design all these thought experiments to help you think differently. And I'll probably get into those too, the thought experiments that I derived for mental cognitive stressing, which is why I can think like I think. But I sound full of myself, but I am different. I've never met anybody else like me. Except, there are always like types of people like this guy, I feel like we would get each other. Though I consider that more fantasy than anything. I wish my laser worked. This is such a badass laser. But the gravitational field or wave generator, because he's got a theory called the Pice effect that maybe I'm wrong. Who knows? But it is in standard physics that electrons orbit, and so it's a null particle, that's a quantum, and so it's not just simply expanding and contracting. It's not just a static field. Or maybe it is, and then string theory is right. Who knows? I'm not afraid of being wrong. I'm tired. So, controlled motion, electrically charged matter, accelerated spin, and accelerated vibration, rapid acceleration, deceleration, transient. Well, what does that mean? He thinks he found a way to bypass the Coulomb effect. And it's an interesting idea to accelerate electrons as quickly as possible, but what about why are there electrons around the nucleus of an atom to begin with? Why do they always want to pull to the center? That's the only thing keeping them around. They want to push themselves apart. There are these sub-quantum forces that are in just these beautiful balances. And so I've been trying to figure it out, how to write it like this, to finish this, so that we can predict all the particles that will be found from CERN, all potential particles, and how they relate to a sub-quantum level. It's just stressing my imagination to its limits. And I'm so close. It's right there. I just gotta let it sit in my brain for a while. So I think. Did I finish my explanation of time dilation? It's just you have to translate to modern times. Not everybody thinks like those guys. In school, I had to do all my math in my head. I still do. I can't do the over-under, you know, when it's like 111 times 20 or something. I can't do this. Well, I couldn't for a long time, and now I know how it works now. I get confused. When I look at that, I would do, this method. If I had to write out an equation for multiplication, this I get. And so I think a lot of limitations in physics and math stem from the inability for people in modern times to think naturally like the older intellects, the older physicists and their systems. And it's kind of like Porsche versus Chevy. One person sees the point of putting a motor at the front, the other one likes to put it at the rear, and other companies like mid-engines. It's only when you try to set limitations and goals that you realize one approach is better than the other. But individually, we don't have a limit or a directive for individuals to enjoy things. That's what makes individuality separated and diverse and complicated, complex network of quantum interference. And I'm gonna get into consciousness apparently. I just wanted to make a video about time dilation. Well, maybe I'll talk about my theories of how consciousness happens later, some other time, through quantum wave cancellations and the neural receptors. But I'm getting off topic. Like I said, it's 4 a.m. now. Jeez, time is just flying. And I do live at a higher altitude, so I'm starting to rationalize why this year just flew by. It barely feels like it even happened. I have to move again. I don't think I'm going to. I just don't care. I mentioned that in the other video, right? The need erases... Oh, that was another point of time travel. So the need erases the need. Like I said, as you travel back in time, you eliminate yourself from reality if you isolate yourself from the event. And so as you travel back, your particles don't exist where they once existed. All the other particles are being replaced back to prior moments and positions and vectors. And so the whole point of this is that time, as we see it, is this is a new vector. So, I mean, you can do it more like this. It should be like this. But that is saying that A goes to B and B goes back to A initially. And so when you isolate from the event and remove yourself, then you are still traveling A to B, B to A. And it's the whole funny oddity of this wave right here, to say that we are going B to A, but we're also going A to B. And all those moments that you encounter, whatever your need is to travel back in time for, stops existing and erases itself. Because it never happened, because you're gone. However, if you isolate, you're going to still have those memories, but you'll have the relief of knowing that it never actually happened. And it's that old time travel paradox. If you travel back and erase your ability to get the time machine, then you wouldn't have the time machine to travel back, which is flawed. So you could still go outside of the event and travel back, but you're never going to have knowledge of the future that you came from, because you're going to be outside of the event, and that replaces all particles back to their prior moments, even within your brain. And if you isolate yourself from the event, you are going to still grow linearly older. You're going to have those memories, but the event's never actually happened, and it resets the probability. And if you use it to grow younger, the same thing happens. You are erasing your memory of the future. Now maybe you can isolate it and insulate your skin cells and just make your skin grow younger and leave your brain alone. I don't know. But then you would slowly grow insane. And so I'm pretty sure they use atomic clocks to measure time dilation. However, they're not compensating for the quantum atmospheric density fluctuations and how gravity warps that through acceleration and impulse, whether you're stationary or not, or you're traveling through space and you're on an airplane and you drop a pencil, it still falls straight down, even though it's traveling with you, accelerated by the plane. To you, it falls straight down. And so it's not time that's dilating. It is merely our ability to measure time that we construct that is flawed.